You'll have to write this down. Okay. Subjective question. Use the chapter on applications of derivatives. And differential equations.
Sir, C option's answer is log 2000 plus, no, 1 minute. Log W is equal to minus e to the power
You,
minus t.
you cannot keep it on log
Yes.
form on the left hand side because there is a restriction on logarithm, right? If
Uh,
you do the integrals, you will get modulus there. So to remove that, we always take the dependent variable on the left hand side and the independent variable is given on exponentials.
yes.
Okay, so transfer that into exponentials and then
W is equal to 2000 e to the power minus e to the power t minus e to the power minus e.
e to the power minus t minus
E to the power minus e.
e to the power minus e. Yeah, I think that is correct. Do the other parts. Yes, how will you solve this problem? There are 4 parts to this question. Okay, so you can either get only one part or you can get 4 parts together. Of course, you'll not get one part. I mean, all of these can be condensed into one part or 2 parts or something. This will be probably a 10-mark question. Okay, everything together. So what is the first part? The first part is, okay, what is the question? The question is, walleyes, which is a type of fish, in a lake at a time t years after 2015. Okay, can be modeled by a function w that satisfies the differential equation dw dt. So that is the differential equation, right? Oops. So dw dt is equal to w into e to the power minus t. But w2 is measured in number of walleyes and w1 is given to be 2000. Okay, it can be shown that t2y, okay, that is given. Most likely in exams nowadays this won't be given, right? This was quite a long ago, 2015. So find the slope of the tangent to the graph at t equals to 1. So slope of the graph, how do we calculate slope? Slope is basically the derivative, right? So slope at t equals to 1, this is nothing but dw dt evaluated at t equals to 1. So this is w1 into e to the power minus 1. So that is 2000 by e. Okay, that is the first part of your answer. Clear? Should not be a problem here.
Yes, yes.
2000 by e. Approximate w2, the number of walleye in the lake in 2017 using a line tangent. So this is known as linear approximation. Okay, linear approximation is actually done in two ways. You can either do it via the tangent, or you can do it via the definition of first derivative. You will get the same answer in both cases. Okay, so what is the definition of first derivative? The first derivative is defined as, uh, let's say, okay, so I'll put a bit of block here. So f dash x is given as limit h tends to 0. What is the first principles for the derivative? How do you calculate derivatives? Yes, anyone? Hey, how?
First principle.
Hmm. What is it? This is also known as the fundamental theorem of derivatives. Can I repeat? How do you calculate the derivative from limits? What is the definition of right hand derivative? What is the first principle of derivatives?
F of x plus h minus f of h by h.
F of x. F of x plus h minus fx by h.
Yeah,
Okay.
this one.
Hmm. So if I remove this limit, what happens then? Is it still equal?
Uncertainty will be there. So we'll put,
We'll put approximation.
yeah,
Okay. So what is this now? So this means h of f dash x is equal to f of x plus h. Okay, not equals to again, approximately equals to minus fx. So this would mean f of x plus h is approximately equal to fx plus h of f dash x. So this is one of the ways of linear approximation. Okay, this from this spot onwards we can derive the Taylor series. Okay, if we use the left hand derivative, we'll get f of x minus h is equal to fx minus h of f dash x. So if we keep on repeating this again and again, because you see that there is the f dash term here, right? So if I put f dashed here, this will become f dash and this will become h double dashed. So if we use the left derivative term again and again, we will get a repeating cycle of terms which we can replace one upon other to get the Taylor series. This is the point from which Taylor series starts. Anyway, I can use this to approximate. Okay, or I can use the tangent. So if I use the tangent to approximate, do they want us to calculate the tangent using the line tangent? Okay, so this method we are not going to use. That is why I told you this method, because if you have to use it somewhere, then you can do it. I just discussed the theory. For this part, we'll calculate the tangent. So what is the tangent? The tangent will be, calculate the tangent, you have the slope and you have the point of contact. The point of contact is this one, w1 is equal to 2000. So that means it is 1 comma 2000. How do you calculate the equation when you have point of contact and slope? How do you calculate the equation of the tangent? Yes? Come on. Exam is tomorrow. You cannot forget the equation of a tangent. So this is y minus y1 into m into x minus x1. M is the slope that we just obtained. So it will be y minus 1 is equal to 2000 by e. No, sorry. It will be y minus 2000, right? So y minus 2000 will be equal to 2000 by e into x minus 1. So always give this in y equal to mx plus c format. So y will be equal to 2000 x by e, and that 2000 will come this side. So I'll get 2000 common, 1 minus 1 by e. So that is the equation of the tangent, right? Now what do I have to approximate? I have to approximate w2, right? So I can just put x equal to 2 here, and that will give me my answer. Okay, so y of 2 is approximately equals to 2000 into 2 e plus 2000 into 1 minus e. So 2000 into this will become 2000 into 1 plus 1 by e, right? Because 2000, if I take common again, this will be 1 minus 1 by e plus 2 by e. So that will become 1 plus 1 by e. Okay. Even if you follow this method, you will get the same answer. Okay. Because both of these are calculating the same point. One is calculating along the tangent line, and the other is calculating the distance from the actual curve. Okay. So both of them are the same thing, and both of them are linear approximations, because near the point of contact, well, at the point of contact, the curve and the tangent touch, right? So they theoretically they should be very close together in the proximity of the tangent, then they will move far away. So you can assume that a curve is like this, and if you draw the tangent, see, in this region the curve and the tangent are very close. So in this particular region we can approximate the curve by the tangent. Of course this will lead to errors as we move further away, and you can see that if you calculate the actual value, it will be a very bad approximation. But this is the logic of linear Taylor approximation as well. This is basically that. So even if you move from linear to quadratic in Taylor equation, Taylor series or Maclaurin series, the approximation will be much better. Okay. So remember, linear approximation is a portion of applications of derivatives. You can do it via the first principles, or you can do it via the equation of the tangent. Okay. So tangent and normal we are done quite a long back. All right. Second part. Is the approximation found in part A an overestimate or underestimate? What do you think? This question is not that difficult. It is just a question of application. What is said here? It can be shown that d2w by dt2 is less than 0. If the second derivative is less than 0, what does that mean? How does the graph look like? Remember, ISI exams, any difficult exams, ISI, CMI, etc., they will stress very much on an holistic approach. That means you'll have to look into the geometrical implications, the algebraic implications, the mathematical implications, and so on. So on. Mostly they will stress on geometry, because it is very, we do not usually train to visualize things. We only solve them, right? Formula 1, formula 2, combine them, get the answer. But visualizing it is not something we practice. Therefore, this question. Okay, so if a curve has second derivative less than 0, it means that it is concave down, right? So concave down means like this or like that, right? We don't know whether it, okay, so we actually know that this is e to the minus t, so it will be decreasing slowly. So this is the graph. right? Part B. I can write as d2 dt2 less than 0. The graph of WT is concave down. If it is concave down, then linear approximation is overestimate. Agree? Because if the graph is like this, then whatever tangent you draw there will obviously be more. It will be an overestimate, right? You will be estimating values here and here. So actual values lie much below it. Okay. Even if it is concave down this way, then also this will happen. Even if it is concave decreasing, then also that will happen. Okay. The actual values will lie much, much lesser. So if it is concave up, that means double derivative is greater than 0. I have taught you all of this. So when you have critical points, there the function turns. And when you have inflection points, where at those points, the shape of the function changes. Okay? Hopefully part B you understood. Part C was the actual differential equation. Use separation of variables. They have given their method also to find the solution with the initial condition W1 equal to 2000. Okay? Let us solve it. So I have dw by w is equal to dt into e to the power minus t dt integrated, and we'll have ln w equal to minus e to the power minus t plus c. So this we have w1 is equal to 2000 at w equal to 1. No, sorry, at t equals to 1, w equal to 2000. Therefore 2000 equal to minus e to the power minus 1 plus c. Okay, this is also minus. So c is equal to 2000 plus e to the power minus 1. Therefore, solution ln w is equal to 2000 plus e to the power minus 1 minus e to the power minus t. Right? So w will be equal to e power 2000 into e power minus 1 into e power, no, it will be divided by, right? Because this is minus. Also I can change it to plus. So e to the power t. It will be 1 over. Okay. So this will just be well here. I think we went wrong because I have to combine all of these, right? If I don't combine this, it will give you an error like this. Okay. So do not do this. This will lead you to the wrong path. Here, first combine the solutions. So this should be ln modulus w, but it's population, right? So it cannot be negative. So transfer it into e to the power, sorry, w will be equal to a into e to the power minus t. Okay, it will be a e to the power minus t. All right. A is basically the constant. because it'll be e to the power c, right? It'll be e to the power minus t plus c. So I can just bring the minus and e to the power c. So a is technically minus e to the power c. All right. Now I can use at t equals to 1, w equals to 2000. Therefore, 2000 is equal to a into e to the power minus 1. Right. So that means I'll get a is equal to 2000 divided by this minus was there. So this will be minus here, or I can just write it as multiplication. So minus here, and a will be 2000 into e to the power minus 1. Now put the value back. W will be equal to 2000 into e to the power minus 1 minus e to the power minus t. Okay, that is the final answer. So a bit complicated, but then again, these problems are meant to be complicated. Okay, it is not complicated as in the solution is difficult, but the particular solution, the putting values and all, is a bit tricky because it's going e to the power, right? So this is a bit concerning. But anyway, we have solved this. So done. Number D, the number of walleye in a different lake at time t after 2015 can be modeled by the function n. Approximate the number of walleye in the lakes as time approaches infinity. It will be in the lake, okay, in only one particular lake. So D would be equal to, we would just have to approximate, right? So this will be limit t tends to infinity nt. This is basically limit t tends to infinity. Hey, you can do this limit 11,000 by 2 plus e to the power 3 e to the power minus t. Solve this limit. Tell me what you get. Yes. Come on, you know what limits are.
Thousand 500.
Yes.
5,500.
5,500 is correct. Because 3 e to the power minus t, that part will go to 0, right? Because e to the power minus t is 1 by e to the power t, and as t goes to infinity, 1 by e to the power t goes to 0. So it will be 11,000 by 2, which is 5,500. Okay. So you got the full experience of writing a subjective answer, and you also got an example of a question on differential equations. Okay. Well, this technically had all of the differential calculus in it. There was no integration. It started from limits, we had derivatives, we had applications of derivatives, and then we went to differential equations via all the subparts. Okay, fine. Now, let us move from derivatives to coordinate geometry. But there will be a bit of derivatives here as well, so that you do not feel lost in the transition. This is a question. A little bit got cut off. So this is the first quadrant. Tan theta is equal to what? Is equal what?
Can we apply tan theta is equal to m1 minus m2 by 1 plus m1 m2 formula? Two by root 3.
Hmm. Others completed. Yes, let theta be the acute angle between tangents and ellipse at their point of intersection. So you have to find out where they intersect. That is the first order of business.
3 by 2
So
comma
how do you
root
find where
3
they
by
intersect?
2.
Intersection point.
Yes.
Go again.
3 by 2 comma root 3 by 2.
3 by 2 comma root 3 by 2 is fine. So you will just have to solve this, right? So x square by 9 plus y square is equal to 1 and x square plus y square is equal to 3. Solve them. You can make y square the subject of formula. I mean, get the value of y square from here, 3 minus x square, and put it there, you will get your answer. Okay. So when you will get x and you will get y. So solving, we have point of intersection. Three by two comma root 3 by 2. Okay. Now what do we have to do? We have to calculate the. We will need the slopes. Okay. So how do you calculate slope? We just did it, right? You can do dy dx. So curve 1, that is given by x squared by 9 plus y square is equal to 1. So 1 by 9 into 2x plus 2y dy dx is equal to 0, which would mean dy dx is equal to, okay, 2 can get cancelled. So you'll get minus x by 9y, all right, dy dx at 3 by 2 comma root 3 by 2. You can just put the values. If you put the values, you will get minus 1 by 3 root 3. Now you do the same for the second curve. That is x square plus y square is equal to 3. Right? So that means 2x plus 2y dy dx is equal to 0, which would mean dy dx is equal to minus y by x. No, minus x by y.
Sir, minus 2 by
So that
root
means,
3 is the answer.
no, not minus, because there is a modulus, right?
Oh, yes, yes, sorry. 2 by root 3.
Fine. So then dy dx again at 3 by 2 comma root 3 by 2. You will again just put the values. So that will give you minus root 3. Now you know that tan theta is equal to slope of m1 m2 by, sorry, m1 minus m2 by 1 plus m1 m2. Put the values here again. You have m1, you have m2. So if you put the values, you will get, what is m1 minus 1 by 3 root 3 minus of minus root 3, so plus root 3 divided by 1 plus, there are both negatives, so I am just writing plus again, which is 2 by root 3. Okay, that is the entire problem. So not very difficult, just you have to be patient. Okay, dy dx you have to calculate for both of these, then you have to get these values, and first of all you have to get the point of intersection. So a lengthy problem, but not difficult in any sense. Okay, next, what chapter are you doing?
Binomial.
Any UGV?
Binomial. That is interesting. Let us do that. What else did you all say?
Any UGB question? Like,
Again, we just did a UGB question.
no, I mean proper last year paper or something.
Last year paper, the solutions are there in the YouTube channel. Last year as well as last year.
Okay.
Okay, I have solved the questions.
YouTube channel.
Look for the playlist. I would have solved a few questions.
Okay.
Last year the problem was on sine rule, if I remember correctly. There was one area problem on sine rule. Binomial. Okay. Do. Mixes everything. Binomials, GIFs. Enjoy. Yes. What happened? Why did everyone go silent?
1 minute, 1 minute. Just 1 minute.
This sum is unnecessarily complicated. It can be
Yes, sir.
done in
Please.
this can be done in 2 steps. So start with 1 minus x plus x cube to the power n.
Is it 1?
1 is correct.
Yeah, I
So
took.
go on.
Yeah, I took as first I put at 1. So first I expanded and written it. So 1 minus x plus x to the power 3 whole to the power n as a0 plus a1x plus a2x square like this. And
Hmm.
then I put at x equal to 1 and then at x equal to minus 1. And then I.
Yes, fine. Fine. So 1 minus x plus x cube to the power n. The expansion will be something like this, right? A0 plus
Yes.
a1x plus a2x square and so on, right? Of course, we don't need to do these, but if there are 3 terms here, it will end at 3n, right? So it will be a n x to the power 3n, right? So use x equal to 1. So at x equal to 1, you have 1 is equal to a0 plus a1 plus a2 plus dot 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 plus an, right? So you have this at, no, it will be a3n because we have 3n terms. Here also I'll put a3n. All right. So now what? Now I can just go for -1. So use x equal to -1, and that will be, so minus of -1, that will cancel out again, and -1 will be equal to, no, wait, this will be 1 plus 1 and -1, right? So again it will be 1. So this will be equal to a0 minus a1 plus a2 and so on. And what will be a3n? We have no idea, right? So I can just write plus dot dot dot. No, it will be minus because the next term is minus dot 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 plus -1 to the power 3n, a to the power 3n, right? Because it keeps on repeating. So if it keeps on repeating, then we can just add them. So this is a, this is b. So adding, if you add a and b, the odd terms will remain, right? So if the odd term remains, no, the odd terms will go away. Minus a1, even terms remain. So a0 twice, right? Twice of a0 plus a2 plus dot dot dot. This will give 1, no, 2, because we are adding them. So that means a0 plus a2 plus dot 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 is equal to 1. Okay, call this C. Now you can subtract b from a. That will give you all the odd terms. Twice of a1 plus a3 plus, we subtracted b from a because we did not want the odd terms to go negative. Even if you do it negative, you'll have to do one more step, multiply by -1, and you'll get the same thing. So all of the odd terms add up to 0. Right? Now I can use C and D to calculate this. because well, this plus one is actually here, okay, uh, not plus one beside it. So it says the box here does not matter. It's all even terms plus all odd terms, right? So using C and D, required sum is 4, no, 1 plus 4 into 0. Okay, you have to use this technique, the one with plus 1 and minus 1. We use this technique multiple times when we are deriving formulae, right? When we derive the relation for the combinatorics coefficients. Okay, last problem, we'll do it from coordinate geometry.
So last stepটা কি হলো বুঝতে পারলাম
আরে লাস্ট স্টেপটা এগুলো 2j, তো এগুলো ইভেন টার্ম আর এগুলো 2j প্লাস 1, এগুলো অড টার্ম। সো সব ইভেন টার্ম গুলো যোগ করলে 1 আসে, অড টার্ম গুলো যোগ করলে 0 আসে।
ঠিক আছে
তো 1 প্লাস দ্যাট ইজ 1।
টোটাল সামটাও পুরোটা 1 নাকি
হ্যাঁ, because all odd terms will add up to 0. So whatever you multiply, whatever you keep on adding here does not matter, right? It'll all add up to 0. And these will, sorry, these will add up to 1 and these will add up to 2. How many ever terms you take does not matter. Their total sum is 1. So even if I end it till a2, I'll get 1, right? However terms it is, no problem. Do this last problem. Yes,
k value 2
k value is 2, I think that is correct. Yes, correct. So how do you solve this? Equation of an ellipse that is given to us, right? And the coordinate. So how do you do this? You can transfer this equation to the trigonometric form, right? If you transfer the equation to this form, then this sum becomes much easier. So the equation of the ellipse, what will it become? Or the point of contact on the axis. How will you describe that? So the equation of the ellipse is x by b square here. So x by b square plus y square by 4a square is equal to 1, right? So if I look into the coordinates in terms of trigonometry, I can just do a is a, the intersection and the coordinate axis, right? So a is the intersection on the x coordinate. So that will just be b sec theta comma 0, and b, the intersection on y axis, will be 0 comma 2a cosec theta. Okay, and therefore the equation of the tangent will be this is x cos theta into b, sorry, by b, plus y sin theta, right? Yeah, y sin theta by 2a is equal to 1, right? So now what is any point on the ellipse? So any point of the, well, we don't need the general point on the ellipse. Equation of the tangent is here, and from here we can calculate these 2 points, right? Put x equal to 0, figure out y, put y equal to 0, figure out x. Okay, that is how you get these points. You know how to calculate the equation of an ellipse, tangent of an ellipse, that is the standard form. Okay, these are formulae. So once you have this done, you can just calculate the area of the triangle, right? So area of the triangle will be, the triangle will be AOB, right? Because A origin and B, so that will be equal to half into, what is the base? I think the base will be the, well, it does not matter, right? Just keep multiplying. B sec theta into 2a cosec theta. Okay, so cancel this and you will end up with AB sec theta cos, AB is sec theta cosec theta. So which is, wait, this is 1 by sin theta cos theta, right? So that is 2 by 2 sin theta cos theta. So 2ab cosec 2 theta. Okay. Now what is the maximum value of cosec 2 theta? Of course it will be 1. So KAB, what will be K? K will be 2.
মিনিমাম এরিয়া বলেছে তো।
Oh yeah. Yes, sorry. So the mistake was mine. Since it is 1 by sin 2 theta, the maximum value of sin 2 theta is 1. Okay. So that is why cosec 2 theta will also be 1. Because if I take the minimum value of 1, it will go to negative. And I cannot divide by 0, right? That is why. Sin theta maximum value to 1. Or sin theta can divide hoche. So max value of sin 2 theta is equal to min value of cosec 2 theta is equal to 1. Therefore, K is equal to 2. Clear now?
Yes.
Okay. So that's it. I will not take up much of your time. Thank you all for joining. All the best for your exam.